Let's understand a heap data structure today. I'm going to take the example of hand of states from the leetcode, and I have already explained this problem in another video, that is in a logic building. So if you go and check the playlist logic building, you can find the hand of states using the heap data structure. I have used two programming language over there, Golang and Java. And today I'm going to explain the same problem using Golang in a detail. So if you have not understood completely, then you can come back. You can continue this video. So let's understand the problem, and then we'll see how to use this heap data structures to solve the problem. So the problem is hand of states. So what it says, Alice had some number of cards and she wants to rearrange the cards into groups so that each group is of group size, and consists of group size consecutive cards. Yeah, so it's a let's see this input. So in this input, what it is saying, like, group this input using this group size 3. So the first thing, we can check whether this is a multiple of 3 or not. So if it is a multiple of 3, then we can return true. We can return not a true, but we can do the further processing. But if it is not multiple of 3, then we can return false. We know that we cannot group using the group size 3. So here it is 9, so that is a multiple of 3, so that's good. So next thing is you can rearrange, this like 1 2 3. So 1 2 3, and once 1 2 3 is done, then you can take like 2 3 4, all the consecutives from 2 3 4, and then remaining 6 7 8, 6 7 8. So these numbers can be arranged using the group size 3. So in this case we can return true. But if you see this example, and this is saying, okay, arrange this using the group size 4, and this is multiple of 4. 1 2 3 4 5. No, this is not a multiple of 4. So in that case, we can return false here. So that's a problem, and how we can solve this problem, let's understand this, and then we'll utilize the data structure, then use the code. Go back to the another screen. Okay, so this is the problem here. So how we are going to solve this? So the first thing is, we first store this value in a map, and we'll also store its count. So this is the value will be stored as a key, and this 1 2 3, this will be stored as a key, and then count will be stored as a value. So in a map, if I store let's say, so is a map, and here I'm going to store 1. So first I will see the 1, and how many 1s are here. That's just only 1. So I will store like this, 1 1. Then I will see the 2. So take the another item 2, and we'll see how many counts. So 2, there are 2 2, so I can have this 2. Then see, like 3, how many 3? There are 2 3, so 3, and this value will be 2. Okay, then 4 1 4, so 1 4. The 5 is there, no 5. 6, yeah, 6 is there, so 6. So 1 7, that's also count is 1, and 8 count is 1. Total is okay, 1 2 3 1 2 3 4 6 7 8. So we added this all data and its count in a map. So next thing is, next step is, now we can store all the keys, all the keys in a heap. So in a min heap, so I'll create the data structure min heap, and in a min heap I can put all this 1 2 3. key. So 1 2 3 4 6 7 and 8. So we know the properties of main heap is like when we remove the item from the main heap, that will be the minimum of all the items. So if you remove the item from the main heap, we'll get 1. Again we'll remove, we'll get 2 and 3. So in that way we'll remove the item from the main heap. So that's the data structure. That's the data structure of main heap, where when we get the item from this main heap, we'll get the minimum item. Okay, so we did that. So that's a step 2. So step 1 is a map. Step 2, we'll store that all the keys of the map to the main heap data structure. And then step 3 is our main logic. So we'll keep removing item from this main heap. So we'll use the for loop, and we'll remove every item from the main heap. And the first item is 1, so we'll remove the first item 1, and we'll remove the first item, and this item gone here. Yeah, we'll not decide whether this item gone or not, but first we'll take the first item from this main heap. We'll check its length is greater than 0. So okay, so length is greater than 0. We'll take the first item 1. Okay, so next thing is 1, and then so the 1 is the beginning of item, and then end item is 1 plus window, that's the group size, that's the 3. So 3, so that means 4. So we'll check item 1 2 less than 4. So the less than 4 is 3. So 1 2 3. So we'll check this 1 2 3 exists in a map or not. And if it exists, then we'll check if the how many count of that number exists. If it is more than 1, we'll decrement and again store that in a map. And if it is 1, delete from the map and delete from the main heap also. So let's see in this example, we'll check first one by one. So we'll check 1 exists in a map. Yes, it exists. And what is the count is 1. So if the count is 1, then we'll delete from the map. So delete it. So delete it, and we also delete it from a heap. Delete it. So that's good. In this way we'll process for each item, and in any place, like if the item doesn't exist in map, will return false. Otherwise at the end we'll return true. And that's the logic, and that if you return true, that means we can rearrange all these numbers consecutive number. See, 1 2 3, and if you start from 2, the next item will be 3, and then 4, all the consecutive. 6, next item will be 7 8. Okay, so we'll check for 2 now. So 2, how many count? So count is 2, so we'll make it 1. So this becomes 1, and we'll not remove from the heap. So that's good. We'll check 3 exists in a map. Okay, that's good. Then we'll decrement this count to 1. Okay, so that's done. And we know that from the heap we have already deleted 1. So this first iteration is done. So it's still within the heap, and we'll check heap size is greater than 0. Yes, it's greater than 0. So what is the next item? So next item is 2. So we'll again take the 2. Then we'll check what is the end for the 2. So for 2, and then we'll add 3 here. 2 3 5. So we need all the item less than 5. So starting from 2, all the consecutive item 2 3 and then 4. We'll check whether 2 exists in a map or not. So okay, 2 exists in a map. And what is the count? Count is 1. So delete it. Delete it from here, and also delete it from heap. main heap. So we delete it because count is 1. Now we'll check for 3 exists or not. Yes, 3 exists. And what is the count? 1. So if the count is 1, delete it, and also delete that 3 from heap. Okay, so 3 deleted. 4, we'll check 4 exists, that's good. Count is 1, so delete this also, and we delete the 4 from heap also. Okay, so we are done with this iteration, and then still we are inside the loop of this heap. So we'll take the top item from the heap, and we get the 6. So we'll get 6 here, and then we'll find what is the end for 6. So 6 plus group size 3 is a 9, so end is 9, so less than 9. So that means we need all the item starting from 6, 7, 8, and we'll check that 6 exists in a map. Yes. And what is the count? 1, so delete this, delete from heap also. So deleting it heap, we'll take the 7 and we'll check 7. What is the count? 1, so 1 means delete. If it is more than 1, then we can decrement, but count is 1, we can delete. 7 also delete. And in the similar way, we can check 8. What is the count of 8? 1, so delete this. First we'll check whether it exists or not. If it doesn't exist, then we can return false. Okay, we can delete from heap also. So there is 0 item remaining in a heap. We deleted all the items. So at the end we can return true, and we can say all these numbers can be rearranged using the group size 3. So the same logic we are going to write in a golang. So let's see. Okay, let's take the example for the so let's create the array first. Okay, so we got this. Take the function. So what is the name of the function? It's is n straight hand. Okay, we pass this array and then group size, return boolean. So that's the function. You can pass the array, and the group size is 3. You can pass the group size. You can print this, and write the function. It takes 2 inputs. One is array of int, and then group size, return boolean. Okay, so our function is ready here. Let's implement this code. So before this, we need a it's a boolean. Okay, first return true. Okay, return true. So we need a data structure. So let's create a data structure. So data structure here is heap, main heap. So define the type. Type is, like you can say, init main heap, and then we can implement 5 functions. So let's do this quickly. first is length. So length is going to return int, return length of h, and function another one is less. It takes two inputs, so I, j, int, and return boolean. So return hi less than hj. So we also see this, like if you make it greater than, then it turns to the max heap. So we'll see that after running. So let's implement another function, third function, in heap swap ij int and hi hj to hj hi. Okay, so there are two remaining functions to be implemented. Let's do that. Let's use the easier one. The easier one is the it's a push. So here we need pointer. Item any. So star h, whatever the new item comes, append star h item. Then that's a interface, so we have to convert to the actual type of that item. So that's a int. So int. So that's done. Implement the last function, h init heap. That's a pop, and it returns the interface, empty interface. So any. So first, okay, so first thing is from the h star h, you can take the last item from this. So the item is, so we can do in a two different way. Let's do that in a fast way. First, I'm going to create a new variable and put the star h there, and then define another variable to find the length. So length a, and the item, last item. So last item from a is l-1, and return the item. But we have to also reflect this thing in a star h. So last item we have to remove from this a. So a equal to a from 0 to l-1, and then put that a to star h. Okay, so in this way you implemented this. Let's see whether our main heap is working or not first, and then we'll do the further logic. Okay, so for that I need to implement container. It's a heap. Okay, let's use the heap here. So what I do, I'll create a main heap object, and I'll say that we have the init main heap, address of this, and initialize this. heap.init, then main heap. Then we can put the item inside this main heap. So just for testing first whether main heap is working or not, I'm going to add some random item here. So let's say heap dot push, let's say 10, and then again heap dot push 20, and heap dot push 9. And I want to get the item from here, so heap dot pop. So this is when I push, then I have to use heap push, and then I have to give this variable name. So that means I'm pushing here, and okay, so let's remove the item from the top. So heap dot pop, and when we do the heap dot pop, it will return interface, like so. I will store that in an element, and I will convert that to the item equal to element and type conversion. We know that's a int. Let's print this, and in this way we know that okay, our heap is working, and then we'll add the actual logic for is in a straight hand. So go run main, type init heap, which line is this, golang 30. Oh, there are other errors. 9.8 init heap. So this is init main heap, not init main heap. So let's do correct this first. Init main heap here also, init main heap. Okay, let's run once again. $11. So what is the problem? 11 invalid operation ji. Where is the ji? Okay, this should be hi. So ji, it will go to here. Okay, now line number again ji. I didn't save. Okay, go 14. So init, oh, 2 times, so not be 2 times. Did I save? Yes. Main go 14.33. So if it doesn't support any, then I might be using the old version of Golang. Check that, Golang Go version. Let go. Okay, so 1.17. So it's a 1.7. It doesn't support any, but in the latest version it supports any. But in this case, if it doesn't support any, then you can write interface like this, and here also we can return interface this. Okay, let's try now. We still have any somewhere. Oh, I didn't save. Okay, try again. 42. It's better now. Heap.pop. Okay, so this is the mistake usually we can do. So when you do the heap pop, we have to provide this object. So main heap. Okay, so we got the item 9. So we'll see here 9 true. So we got the 9. So we know that the main heap has the smallest item at the top. So we got the 9. Okay, and the next item, if you run, we'll get the 10. And also let's check this thing also. If I change this to less than to greater than, and then turn to the max heap, and in this case, our expectation is 20, so 20 will be at the top. So when we remove, we'll do the pop, then we'll get the 20. So let's save it and run it. Okay, we got the 20. So our heap data structure is working fine. So we need main heap, so that's why going back and changing to less than. So that's the way we can change a heap to the main heap or max heap. Also, we can save few lines here. So we did a star h, but if you do not want to introduce a, then that also works. But how will works? Let's see. Star a, and when you do like it's the star h, and if you do not use the a variable, and if you use the star h, so it will not work. If you use the star h directly like this, we have to wrap within the bracket. So I'll add this in a bracket, and here that's fine, the star h. Yeah, but item, okay, we got the last item, and then we have to update here star h. That's we have to first wrap this in a bracket, and then we need j from 0 to l-1. So in this way we can remove few lines and save a few lines here. So let's run this. We are still getting 9. That's working fine. If you can check this also. If you remove a star h, then it's not going to, if you remove the bracket, it will not work. Let's try. Yeah, it will complain, does not support indexing. So that's why we have to wrap this within the bracket. Okay, so that's the way we can implement this main heap here. So that's good. Run it once again. Yeah, okay, that's working fine. So 9 true. Okay, now let's go for our original logic. So in the first step, what we're supposed to do is everything, we store this in a map. Okay, so let's do that. So step 1. So we need the main heap in it, but we didn't need this guys here. So let's remove. So first iterate from this a. So I do not care in this index. So I'll just add this v here, range, and say a. So we'll get 1 by 1 item in the v, and we store that to the map. So we'll create the map first. Map, the key type is int and the value type is also int. So let's store that in an mv. So first time v comes, we know that count is going to be 1, but before that we'll check whether this item already exists there or not. If it exists in a map, then we increment the count. So mv, and then that I can say the count. Okay, so in this way we'll get the item from mv. We'll check if okay. If okay, that means if the item exists. If item exists, then this item already exists, then we just increment the count. So count, whatever the count is there, count, we'll do the count plus, and then we can store m v. See, this is the key, whatever the value is the key, and then it's a count. So count. Else, if the item doesn't exist there inside the map, then we'll use this one. mb1. Let's check this step 1. So this is our step 1. So step 1, store this array value and its count. So we did that. Let's print this and see it's working fine or not. Empty println m equal to m. Print this, save it and run. So we'll get count of 1 is 1, 2 is 2, 3 is 2, 4 is 1. So that's a correct number. I see 1, count is 1. And for the 2 repeats twice, so the 2 count is 2. And 3 also repeats twice, the 3 count is 2. And 4 repeats 1 time, 6 repeats 1 time, 7, 8 all repeats 1 time, so that's count is 1. Okay, so till here step 1 is done. Step 2. Step 2 is store all the keys of map in main heap data structure. Main heap. Okay, so let's do this. So let's iterate from map. So map, and the way we'll iterate is give heap range m, will get k and v, so key and the value. So as soon as we get the key, we do not care the value, whatever the count, we do not care here. We just store the key in a map, in a heap. So get the key out of map and store in a main heap. So our main heap is this. So heap dot push main heap and then k. So in this way we store all the keys of the map in a heap. Now step 3. Step 3 here. Okay, iterate through heap items and the logics items and implement the logic there. So let's do here. We can check, the for heap dot length greater than 0, then run it. Okay, so we'll try to get the first item from this heap. So if you do not want to remove the item but still you want to get the first item, then we can use this way, a star heap. Oh no, it's not. It's a heap dot pose. Okay, so you can do, it's like min heap length, you can do in this way. Okay, so take the top item. So top item here is min heap and then 0. So if you do this way, then we do not have to remove the item, but we can get the top item from the heap. So that's the top item we got, and that's I can say our begin item, and our end is top item plus group size. That's the end. Now use the for loop here, but before that I think we forgot one logic here. Before doing all these operations, we can check one things here before this. Like first thing is if it is multiple of our group size or not. So if I can check if length a divide by group size divisor, but we need like not. If, or you can say not equal to 0. So that means if it is not, it is not, this size is not multiple of group size, then we can return false here itself. Okay, so that's good. Next thing is here we got the end item. We need to have another for loop where I can say our begin item is top item, and then I less than end or end item, and then I plus plus. So we'll get, the first time we'll get 1 from the heap, and then from or end is, end is like 1 plus group size is a 4 less than 4. So we'll get 1 2 3. We'll check, we'll get 1 2 3 first, this inner loop, and we'll check that item exists in a map or not. So first I'll check, okay, map I do not care the value, so just okay. I'll check whether it exists or not. If not okay, then return false here itself, because if the item doesn't exist in a map, so because we want the consecutive items, so take the 1 and then consecutive is 2 3, it goes till end 1 2 3. So if any of the consecutive item doesn't exist in a map, then we can return false otherwise. Now the next thing is, if it already exists there in a map, it exists there, then we can check the count. Okay, so in this case we need the count. Okay, let's see, add the count here. Okay, now we'll check if the count is greater than 1, count is greater than 1, then we have to update the map. So if count is greater than 1, then we have to update the map, and it's a minus count -1. So in the I go here and update this to count -1. Okay, that's done. If count equal to 1, then we can delete from the map and also delete from the heap. So it's a delete and from the map you can delete this item and also delete from heap. So how to delete from heap? It's a pop. So I'll do the heap dot pop, and so mean heap. What is this? That's name is the mean heap. Yeah, so mean heap. Yeah, done. Okay, so in this way we'll done with the first item of the heap, and then we'll take the another item, and at the end we'll return true. So let's see the syntax error, run it, and it should return true. Yeah, it's returning true. That's good. Let's try to take another example. Like if I add one more item here, 9, does it work? No, because this is not the multiple of 3. So save it. Okay, return false. Let's try another thing. Let's say, okay, 1 2 3, that's fine. 1 2 3, and then if I start from like 4 5 6, that's also good. So return true. Yeah, it's done true. What about if I do like 1 2 3 and 4, let's say something, let's see another way, 4 5 6 7. What about this? Does this work or not? True, with 5 6 7. If I make it 60 or 66, what about this? So that's returned false, because 1 2 3 is good. Then we need like 5 6 and 7, the consecutive, but there is no 6. So 66. So that's why return false. Okay, so that's all about this hand of a straights problem. Yeah, that's all for today. Thank you.